last unit for this lesson. So we have talked about simplifying rationals. We talked about adding them, subtracting them, multiplying, dividing them. So today we're going to talk about solving equations that deal with these things. All right. So let's just dive right in with some examples. This. Now there's 2, right? 3 over this equals 2 over x. It's an equation now because there's an equal sign. So we want to solve it. We want to get x alone. All right. Maybe you remember back in the day in baby school, if you had something like this, how would you solve that?
I would do 2 and x, 3 and 5, and 2x would be equal to 15.
Yeah, you would cross multiply, right? Guess what? It's the same thing here. That was so much applause. It's 2 rational expressions. Those are 2 big fractions, so just cross multiply. 3 times x is 3x, and 2 times x plus 5. I got to distribute that. Really? Well, I'm so glad. Pretty easy, huh? Not too bad, right? You feel okay about that? I know I solved the equation pretty quickly. The thing you need to see right now is the cross multiplying. Yeah. Oh, yeah, sorry. That's a good way to think about it. Yes. Because 2 times 5 is 10. Oh, I subtracted 2x. Yeah. All right, let's do one more quickly. Actually, why don't you try that one on your own for like a minute. Ready, set, go. What do you think you should do first? You still want to do cross multiplication? Well, if you, I'm just saying, if you do cross multiplication, what happens to this? we don't leave them behind. No man left behind. What? To make them the same. Yeah. Yeah. So here's the deal, guys. Here's the deal. If there is more than one fraction on one side, you cannot just dive right in with cross multiplication. If you notice, when we do cross multiplying, there's only one thing on each side. Does that make sense? So if there's multiple, you can't just do it. Here's what you got to do. There's 2 ways to think about it. 1, you can try to get common denominators on this side and combine them. Does that make sense? So you could say, oh, to make this 6, I got to multiply it by 2. That would be 4 over 6. And then you could combine those, right? And then you could cross multiply. You could do that, all right? You could. I'll tell you that there are some problems where this does not work as well. So there, yeah. No, all we're trying to do is get common denominators. Does that method make sense? Like, get common denominators, put them together, cross multiply, then it's the same thing. There's another way to do it. I'm going to show you that way too. Okay? Let's say you wanted to make each of these have the same denominator. So let's say you want to get common denominators for all of them. This is the question, what would the common denominator be? It'd be 6, right? You'd multiply this by 2, you'd multiply this by 3. So the common denominator would be 6. Get what I'm saying? Okay, so here's the trick that I'm going to pull. I'm going to multiply everything by that. Here's what's going to happen. I have to multiply each piece by 6, because that's what the common denominator would be. You guys tracking with me here? Well, 2 times 6 is 12 over 3. It's 6 times 3x minus 1. I'm not actually going to multiply that out yet. You'll see why. 5 times 6 is 30 over 2. Oh, and this is over 6. Sorry. Because that's what the common denominator would have been. All right? You're multiplying it by 6. That's not 6 over 6. That's 6 over 1. And you're multiplying fractions here, right? You okay with that? Okay. Oh, thank you. Yeah, so guys, here's what happens. Stuff's going to look pretty nice here. What's 12 over 3? What happens here? 6 cancels, man. It's 2022. We're canceling. Cancel everything, okay? So this is plus 3x minus 1. 30 over 2 is 15. And now we could solve this. So it's 3x, 4 and negative 1 is 3. Subtract 3, you get x equals 4. And you got the same thing. So guys, did that make a little bit of sense? So again, there's 2 ways to do it. First way, get common denominators, combine them, and then do cross multiplication. Second way, figure out what the common denominator would be, multiply everything by that, and it'll cancel every denominator. And then you're just left with an equation. I'm glad you asked. Are we good with this one? All right, let's do another one then. This one. What's different from this one and this one? One of them's not a fraction. The other one, it's technically a fraction. The denominator is now a polynomial, right? It's not a number. It's going to be a little bit different. Just a little bit different. Let's do it this way. Let's do it this way. If you were going to get common denominators, don't think about this too hard. What would you make the denominator of this thing? Y minus 5. Not that bad, right? So we're going to do what we did here. Multiply everything by y minus 5. I'm going to switch colors. You could, but this way is going to be easier on one like this. Yep. Multiply everything by y minus 5. So it's 4 times y minus 5. Oh, am I? No, I am. I am. Yes. Okay, go away. Nope. Yep, there it is. Okay. So I just multiplied everything by y minus 5. I'm not actually multiplying it out yet. Why am I not multiplying it out yet?
I don't know, but I feel like it's the same exactly.
If the other way makes sense, just do it.
No, I know, but I want to know why this one is easier because I feel like it will be the best.
Well, gone. Distribute. 4y minus 20 plus 2y equals 8. Do you think you can solve that? Yeah? Add 20, 2y equals 28, y equals 14. Unbelievable. Oh, yeah, sorry, I thought it was negative. Yeah. Yeah, it's 6y. 6y. Okay, so what does that mean y is? 28 divided by 6, is that a good number?
No, it's 4.666.
28 divided by 6. Can you reduce it? 4 divided by 2. Divided by 2, you get 14 over 3. Yeah? Okay. That's all right if it's a fraction. That's okay. Did that make a little bit of sense? If you wanted to do the thing where you got common denominators here, you could. You just multiply this thing by y minus 5. You'd combine the tops. You'd cross multiply. It'd be the same thing. You get the same thing in the end. I personally think this way is a little bit easier sometimes. Maybe it's just because I like to watch everything get canceled. I don't know. Maybe it feels good. Who knows? Maybe math is fun. Maybe.
This part of math I love next time. I
Mm.
love this crossing because it's so
Mm.
and it just acts like calculus.
Well, good. What? I know.
That's weird.
So what happens? You said this is what happens when that happens. What happened? Oh. Well, yeah. What if I told you I don't have Twitter? Okay, try some.